I'm going to go over free response question number 5 from the 2021 AP Calculus BC exam. We have y equals f of x being the solution to a differential equation, and we have an initial condition. And for the first part, we have to write the second degree Taylor polynomial for f about x equals 1. All right, so let's go ahead and do that. So we know that for our Taylor polynomial, we need to know what f of 1 is. We need to know what f prime of 1 is. And we need to know what f double prime of 1 is, because we're doing the second degree. Well, f of 1 is right here. It's 4. F prime of 1, well, here's our f prime of x. And don't worry about this y right here, because when you plug in 1 right here for the x, natural log of 1 is 0. So no matter what y is, f prime of 1 is going to be 0. And f double prime of 1 is right here. It's 4. All right, so we know that our second degree Taylor polynomial is going to be 4 times x minus 1 to the 0 over 0 factorial. This is 1. You don't have to write it. Up to you. Plus 0. I'm not even going to worry about the rest. Plus 4 times x minus 1 squared over 2 factorial. So here's our second degree Taylor polynomial. Now we have to use this polynomial to approximate f of 2. Well, f of 2 is going to be approximately equal to what I get when I plug in 2 for all the x's right here. So again, this part is just 1. I don't care about that. So I have a 4 plus 0 plus I have 4 times 2, because we're using 2, minus 1 squared over 2 factorial. And this is my Taylor approximation for f of 2. And we are done with part A, and we will move on to part B. Part B is an Euler's method question. So using Euler's method, starting at x equals 1, using 2 steps of equal size, we have to approximate f of 2. All right, well, I'm going to do this here. I'm going to make a little table. So my x and my y and my change in y, because that's how we're going to be able to calculate the f of 2. Well, we have to use 2 steps of equal size. So we know we're going to be using 1, 1.5, and 2. All right, here's the deal. When x is 1, y is 4. And then my change in y is going to be my change in x times the first derivative evaluated at this point right here. So again, when x is 1, plug in 1 right here, you get 0. So change in y is 0. Let me get rid of that thing there. So this is 0. All right, so that means that my change in y from 1 to 1.5 is 0. So that means my new y value is still going to be 4. All right, and then here, let me make a little divider right here. Divider right here. And then for this part, again, my change in y is going to be my change in x times the first derivative evaluated at this point now. So this time I have to plug in 3 halves for the x's. So I still have the 4 here for the y. And then I have 1/2, or well, 1.5 times the natural log of 1.5. I know this is kind of messy here. Let me write this here. Well, we can just leave it like this, because my new y for here is just going to be this plus this. So I'm going to say that f of 2 approximately equals, don't put equals because you will lose a point, we're approximating here, 4 plus this right here, which is going to be 1/2 times 4 times 1.5 times the natural log of 1.5. And this is the end of part B. And we can go on to part C. Again, no scoring guidelines have been released, but I'm going to take a pretty good guess that part C is going to be worth 5 points because it is a separation of variables and an initial condition problem. So we just have to find the particular solution to this differential equation with this initial condition right here, which again they gave here. So first part right here, separate variables. I'm going to divide both sides by y, multiply both sides by dx. So I have 1 over y dy equals x, natural log of x, dx. And now that my variables are separated, I can integrate both sides. All right, here we have x times the natural log of x. I have to use integration by parts to do this. So I will choose a u and a dv. Since I have this logarithm right here, I like to use that as my u. So I'll let u equal the natural log of x. And therefore, du, just differentiate right here, will be 1 over x dx. And then my v is going to be the other part, the x dx. Well, my dv is going to be the x dx. And then when you integrate here, you'll get that v, I'll say, and v equals 1/2 x squared. I don't know exactly how they would be scoring the integration by parts on the free response question, but I'm hoping that the way I'm doing it right now would be okay. So we can therefore conclude that the integral of 1 over y dy equals, well, for our integration by parts, when we have the integral of u dv, we know that it's going to be equal to u v. So we have 1/2 x squared natural log of x minus the integral of v du. So let's see what we have here. We have v, which is 1/2 x squared, times du, which is 1 over x dx. All right, let's get some more space here. Come on, there we go. Okay, let's do this right here. We have natural log absolute value of y. And I'm not going to put down plus c here. I'm going to put down a plus c on the other side. We have 1/2 x squared natural log of x minus, let's see, I'm going to bring the 1/2 outside of the integral. And then x squared over x is just x. When you integrate that, you get 1/2 x squared. So I'm going to need another 1/2 right here, x squared. And, oh, I'll just clean this up. Why not? Make this 1/4. So we'll say this is minus 1/4 x squared. And we have an initial condition. I know it's not on the screen anymore, but it was that f of 1 equals 4. So when I plug that in right here, oh, and I'm going to have a plus c right here before I do that. So I have the natural log of the absolute value of 4 equals 1/2 of 1 squared times the natural log of 1 minus 1/4 of 1 squared plus my constant. And let's see, I have natural log of 4 equals, this is 0 because natural log of 1 is 0, equals negative 1/4 plus c. Therefore, c equals 1/4 plus the natural log of 4. And now I can go ahead and say that the natural log of the absolute value of y equals 1/2 x squared, natural log of x, minus 1/4 x squared, plus the c, which is 1/4 plus the natural log of 4. And now I just have to do a little work to solve this for y. First, let's talk about the absolute value. We have the initial condition f of 1 equals 4. So we no longer need the absolute value here. I'll leave the absolute value as it is right now, and I'll just exponentiate both sides. So exponentiate, exponentiate, cancel these out. So I have the absolute value of y equals e to the 1/2 x squared natural log of x minus 1/4 x squared plus 1/4, and e to the natural log of 4 is just 4, so I'll just put down a 4 in the front right here. All right, now we can see about the absolute value, because we know that we're using the initial condition f of 1 equals 4. And if you plug in 1 right here, it will satisfy this, because basically you'll have e to the 0, right? This, when you plug in 1, you have a 0 here, and then you have negative 1/4 plus 1/4, and that should equal 4. So I do not need the absolute value. I want that to be positive. So I can just say y equals 4 e to the 1/2 x squared natural log of x minus 1/4 x squared plus 1/4, and this is it. Be sure that you write this carefully so that it's clear that all of this right here is in the exponent for the e.